I'm going over the concepts of how your vape works. I'll show how the atomizer works just like water flowing through a hose. If you've never built before, don't let this keep you from starting. You don't need to understand all of it. This is a dripper atomizer with 3 posts. The center post connects to the positive side of the battery, and the other posts connect to the negative side of the battery. Since this is only a single coil build, we do not need to use the extra posts. I'll draw this out in a diagram, so it looks something like this. When I pour water into the funnel, a current of water flows through. Something similar happens when you turn on your vape. Instead of water, a current of electricity flows. Water flow, for example, could be measured in gallons per minute, but electrical current is measured in amps. So when you say I equals 2 amps, you're saying the current is flowing at a rate of 2 amps. When current flows through the wire, it causes friction, and that friction is what generates the heat. Power is the rate that the current is converted to heat, and this is measured in watts. Why does the flow rate increase when I raise the hose? It's because of the pressure difference. The higher the water level, the more pressure there will be. With the vape, voltage is electrical pressure. In simple terms, voltage pushes the current through the wire. When you raise the voltage, you're raising the electrical pressure, so the current flow will increase and the power will increase. You can see the coil is brighter at 6 volts versus 3 volts. The contrast is a little high, but it's more noticeable if you look at the reflection. If we use a thinner hose, the water slows down. The same thing happens when you switch to a thinner wire. The current has a harder time flowing. In other words, there's more resistance against the current flow, and resistance is measured in ohms. Basically, if you have a 28 gauge and a 32 gauge wire with the same length, the thinner 32 gauge wire will have the higher resistance. Higher resistance translates to less current flow and less power. But what this also means is that you would need less of the thinner wire to get the same resistance as the thicker wire. Even though the resistance, power, and current are all the same, the surface area, length, and diameter of the wire is different, so it affects the vape differently. This will need to be explained in another tutorial. What we just went over about the relationship between current, voltage, and resistance is known as Ohm's law. The equation is I equals V over R. Combined with the power equation, you can rearrange these equations to find the values you want. More importantly, it's used to calculate resistance limits for cell phone vaping and battery safety. Remember, you do not need to memorize all this to build. There are charts that can be used. We will cover this in the following tutorials.